All right, welcome back to part two of our notes for today on these rational functions and their discontinuities. And the nice thing is this is a Friday, so this will be our last video for today, so a little bit shorter. So now let's just kind of recap where we were. So you guys had completely filled in this chart for you, and you can check the answers to the key. And of course, I popped up some information as you were filling it in from the Ed puzzle. But the idea is that anytime that you cannot remove a factor, you will have a discontinuity that is infinite. Anytime you can remove a factor, then you have a discontinuity that is a point discontinuity. So the three facts that I wanted you to get out of this kind of discussion was that first, discontinuities always occur at restrictions. And it may not be the only time they occur, but they always occur at restrictions. And for rational functions, that would be whatever makes the denominator equal to 0. Our restricted values here that we just found by setting the denominator equal to 0, and I'm including it more general than for rational functions because we, of course, have talked about many functions that we have. All right, so restricted values whose factor is removable, then that is a point discontinuity, and there will be a hole in the graph. Make sure that for rational functions, that just means that you factored it, you canceled, and it canceled out completely out of the denominator. So that's what we're looking for removable. And then restricted values whose factor is non-removable are infinite discontinuities, and the graph would have a vertical asymptote. And for rational functions, even if you could cancel some factors that had that, you may not be able to completely remove it from the denominator. If it is still in the denominator in Fred, the reduced version, then it is a vertical asymptote that you're looking for. Now, I went ahead and pulled in, these are the same four functions that you've been investigating. So I just added in their simplified version and the x values at where you have a point discontinuity. I went ahead and added those to this chart already for you. So you can hit pause, of course, and add them in yourself. But what we want to look at is how do we figure out the location of the hole? Now, on all the graphs that I had, I pretty much gave you the location of the hole. I said, here are the y value of the hole. And that's going to be important to find. And remember I said that pretty much what we want to do is we always want to ask Fred whenever there's something that we want to know. And so the idea of asking Fred is after we have simplified, kind of the point of why we had this exception over here is that this exception, sorry, right here, where x does not equal 3, the reason we write that exception is because this simplified version, you can actually plug 3 into that simplified version and you will get a value. That is not the value of this f of. If I was going to do, it's kind of as a side comment, if I was going to do f of 3, f of 3 is undefined. But then when I go to plug it into the reduced version of that, so f of reduced at 3, we can actually go ahead and plug that in. So if I plug in 3 into here, you're going to get, 6 plus 1, 7 over 3 plus 2, 5. You're going to get 7/5 on that. So as you can see here, even though f of 3 is undefined, and that's what we would always say the value f of 3 is, that by plugging 3 into this reduced version, we get this 7/5, which this is not the value of the function, but it does tell us the location or the y-coordinate of the hole. And so that was this idea of where I said, ask Fred because he knows everything. So Fred is who you would go to ask about the reduced version. So you guys are going to go ahead, and this is kind of going to be the end of this for me. I'm going to pop up some questions in Ed Puzzle for you. Go ahead and ask Fred, quote unquote, even though technically it's Gred and Hred and Fred here. Sorry, I'm making a joke. But figure out the reduced version of this, find the coordinates of the hole. You're going to answer the questions that I have in Ed Puzzle, and then based on the information on the table above, How do you find, give me a two-step procedure for finding the y coordinates of the whole, which should be fairly obvious at this point. Now, the other thing that I'm going to do is just talk about what I would like you to do for kind of classwork slash homework. Now, the first thing that you're going to do over here, down in your OneNote notebook, here's an FRQ right here that I would like you to do. That we're going to consider that classwork. So work on that after you have finished this little portion of the video. And then your actual homework that you're going to have is at the end of the class notes. Scroll down through to where we were. You have this worksheet on rational functions. So you basically have two worksheets and an FRQ that you guys are going to be working on for homework. They're not too bad. I already did the key to them, so you can start checking them in your OneNote. But they are fairly fast. A little practice factoring, a little practice canceling, and then making some conclusions about what you know about rational functions. All right, so that'll wrap up our next to last week in the quarantine school version of pre-calculus. So we have next week, we have three more classes. Pretty much in terms, you can kind of see over here in my OneNote that in terms of our instructions that we have, on Monday, we're going to be looking at connecting rational functions to their graphs. So we're going to do a little bit more detail about, well, what if you had to graph? So a little bit of a quick review there. We're going to be graphing rational functions. So in that one, instead of me discussing things about the graph, now you're going to have all the skills that you need to actually go ahead and from scratch, no calculator, graph a rational function. And then we have on Friday just three classworks of some FRQs to practice, and then we are going to call it summer vacation. I will leave these videos up as well, just kind of giving you a heads up. If you are taking calculus next year, these videos are very, very important. So I'm going to leave them up through the summer, and I'll probably add them to the Calc 200 and the AP calculus classes, both of which I am teaching next year. So we definitely want you to be able to have this review kind of coming into both calculus and Calc 200 and AP Calc next year. So hopefully you're hanging in there with me. I really appreciate those of you that are still emailing me, but just know that you are going to be responsible for this information at the beginning of next year. So good job so far. Hopefully this has been not too bad of a finish for pre-calculus, since we are reviewing something that you technically learned in Algebra 2, but super important for calculus next year. All right, I'll be back next week. We will have 3 more days of lessons, and then I'll do a little goodbye video. And on Friday, because I do miss seeing your faces, and it's just not the same being at home doing these videos as it is being able to interact with you guys in class. Hopefully by next fall, we want to be in a better place where we can be back together in the school building. All right, so I'll see you. Look forward to last videos for next week. Have a good weekend.